Hey guys, how's it going? Today what we're going to do is we're going to start Unit 11, which is on sequences. And we're going to break the sequences unit up into a whole bunch of different videos. So the first video that we're going to talk about is something called recursive sequences. And you guys did learn about this in Algebra 1, so you may remember. Now, a recursive sequence is a sequence that uses the preceding term to define the next term in the sequence. So what that means is a sequence is just, a bunch of numbers listed out. Okay, a series, it's just a bunch of numbers listed out. And a recursive sequence uses the term before it to help you find whatever the next term is going to be. Okay, now, I don't know if you recall this from Algebra 1, but when you go to list terms, right, a sub 1 would be the first term. A sub 2 would be the second term. A sub 3 would be the third term, A sub 4, and so on, okay? So the little subscript here tells you what term you're on. So let's say we were looking at the numbers 2, 4, 6, 8, okay? So A sub 1 would be equal to 2. A sub 2 would be equal to 4. A sub 3 would be equal to 6. And A sub 4 would be equal to 8, okay? So basically this is saying the first term equals 2. The second term equals 4. The third term equals 6. The fourth term equals 8, and so on, okay? If you wanted to find the fifth term, you could see the pattern. We're just adding 2 to get from one term to the next. So if you wanted to find the fifth term, you would just add 2 more to this, and we would get A sub 5, right? The fifth term is equal to 10. Okay, now we're going to talk about 2 different types of recursive sequences right here. The first one is called an arithmetic sequence. And I'm going to jump right down to this. I'm actually going to highlight it here because this is really the main point. In an arithmetic sequence, you add to get from one term to the next. So see this sequence I just listed out here? This would be arithmetic. Didn't I say we're adding on 2 to get from one term to the next? Okay, plus 2, plus 2, plus 2. So this would be arithmetic. Now, if you look at some examples down here, okay, here's an example of an arithmetic sequence. 4, 8, 12, 16. What I'm doing is I'm adding 4 to get from one term to the next. Now, if you look at this, these numbers are going down. But since we said what are we adding to get from one term to the next, if the numbers are going down, it means we're adding a negative. So here, we're adding negative 3 to get from one term to the next, which we know adding negative 3 is really just the same thing as subtracting 3. Okay, now let's look over here, geometric sequence. Okay, I'm going to highlight this because this is important. It means we're going to multiply to get from one term to the next. Okay, so if you look down here, here's an example of a geometric sequence. 3, 6, 12, 24. If you look, what are we multiplying by to get from one term to the next? Well, we're multiplying by 2, right? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24, and so on. Okay, and we put dot, dot, dot because it just keeps going. If we look at this example, see how the numbers are getting smaller? If they're getting smaller, it means we're multiplying by a fraction. So if you look, you want to say, well, what are we multiplying 8 by to get to 4? Well, isn't 4 just half of 8? So what that means is we're multiplying 8 by 1/2 to get to 4. Again, if you multiply 4 by 1/2, it means you're just cutting it in half. So that gets us 2. Okay, 2 times 1/2 would be 1, and so on. So when we're multiplying by 1/2, I mean, really, isn't that the same thing as just dividing by 2? Okay, so these are 2 types of sequences we're going to talk about here. Now, for for an arithmetic recursive sequence and for a geometric recursive sequence, these are the 2 formulas that we're going to use. So let me show you how they work. Okay, if you look, they both start off saying A sub 1 is the first term. Okay, so first thing you have to do is you have to say this is the beginning of my sequence. This is my first term. So for example, see this one right here, 4, 8, 12, 16. This says A sub 1 equals 4. 4 is the first term. Whereas when you look down here, 10, 7, 4, and so on, look, A sub 1 equals 10. Okay, this is my first term. And if you look at these 2 examples, see, they're just listing out A sub 1, and they just say what the first term is. Now, in a recursive sequence, remember, you want to give it a rule that tells you what you have to do to get from one term to the next. So for example, our rule up here was we were adding 2 to get from one term to the next. Now, if you look here, this says A sub n is equal to A sub n minus 1 plus d. Now, I'm just going to tell you, when you see A sub n minus 1, if A sub n is the current term you're on. And the reason I'm saying sub is because this is a subscript, okay? And this is where we write the number of the term that we're on, right? This is the first term, the second term. So here, if we're on, we say the nth term, but let's say we were on the second term, right? Let's say instead of saying a sub n, let's say this said a sub 2. If we were on the second term, then we would need to take the previous term, okay? And the reason why this is the previous term, think about it. If we replace this n with a 2, isn't 2 minus 1 just 1? So this is a sub 1. And isn't a sub 1 the term before the second term? Or let's say we replace this n with a 5, okay? Then we'd have to replace this n with a 5. And isn't 5 minus 1 just 4? So that would be a sub 4, which isn't a sub 4 the term before a sub 5. Look, here's a sub 5 and here's a sub 4. So whenever you have a sub n minus 1, when you subtract 1, it tells you to go back one term. This is representing the previous term. So I'm going to write that. So this is telling me to find whatever term I'm on, you're going to take the previous term and you're going to add on d. Well, what does d mean? D, look, it says it right here, it stands for the common difference. The common difference is what you're adding to get from one term to the next. Okay, so like up here, remember I said we're adding 2 to get from one term to the next? D would be equal to 2. Now if we look at this one, aren't we just adding 4 to get from one term to the next? So our D would be 4. Okay, so if you look at how this rule was written, remember we said a sub 1 is equal to 4 because that's our first term. And to find any other term, that's equal to the previous term plus 4. Okay, let's look at this example down here. This says our first term is equal to 10, which you could see right there. Now this says to find any term you want, that's going to be equal to the previous term. And you could write plus negative 3, but remember we said that, you know, when you add a negative, it's the same thing as just subtracting 3. Okay, now let's look over here at our geometric sequences. Okay, we still write the first term is equal to 3, right, because that's our first term. And remember how we said that we're multiplying by 2 to get from one term to the next? Well, if we look at the setup of our formula over here, we could see that if we want to find any term, that's going to be equal to the previous term times r. Now, r stands for the common ratio, and the common ratio is just what you're multiplying by to get from one term to the next. So if we're multiplying, in this example, each term by 2, we're going to replace that r with a 2. Okay? Now, if you look down here, instead of writing a sub n minus 1 times 2, I wrote 2 times a sub n minus 1. Either way is fine. You could put the times 2 at the end, or you could put it in the beginning. Because remember, multiplication is commutative. It doesn't matter what order you write it in. Okay? But just like normally if we're writing a number and then a variable, we write 2x instead of x times 2. So that's why I like to put the number in front. But that's your call. Okay, and then finally, if we look at this example down here, so we see the first term is equal to 8. So that's why we have an 8 right here. And then you could see, oh, I hit mute, sorry. Then to see over here, to find any term you want, you take the previous term, a sub n minus 1, and you just multiply it by 1/2. Okay, that was a lot to take in on one page. That was a huge introduction, but now we're going to take a look at some examples, so we're going to apply this. Okay, so if you flip to the next page, let's take a look at number 1. So example 1 says, write a recursive formula for the following sequence. Now, first thing we want to do is we want to look at this and say, well, is this arithmetic? Are we adding to get from one term to the next? Or is this geometric? Are we multiplying to get from one term to the next? All right, so here, I'm sure a lot of you guys can see that we are adding a constant term to get from one term to the next. Now, if that's hard for you to see, you can actually kind of use your calculator to help you out a little bit by working backwards. Okay, if you want to see if it's arithmetic, you can just take the 22.5 and subtract the term before it. And when you do that, it gives you 4.5. Now, let's go to another term. If we take, let's say, the 27 and subtract the term before it, it also gives us 4.5. If you do that for any of the terms, take any term and subtract the term before it from it, it'll give you 4.5. So what that means is this is arithmetic. We're adding to get from one term to the next. Okay? If that didn't work, you would want to see if it's geometric. So instead of subtracting to work your way back, you would divide by the term in front of it and see if you get a consistent answer. Okay, but here, like we said, no matter which term you start at, if you subtract the term in front of it, it gives you 4.5. So what that means is not only is this arithmetic, but our common difference is 4.5. Okay, that's what we're adding to get from one term to the next. So if we look here, we first have to define our first term. We're going to say a sub 1 equals, and in this case, it's 18. So a sub 1 equals 18. Okay, then we need to say a sub n is equal to the previous term, so a sub n minus 1, and then plus whatever we're adding to it to get from one term to the next. So like we said, we're adding 4.5 to get from one term to the next. And this right here would be your recursive rule. And I'm sure some of you guys remember this from Algebra 1 because you did do this in Algebra 1. Okay, let's look at number 2. And number 2, here's our first term. This is saying, ready? This has the coordinate 1, 4, and then 2, 12, and then 3, 36, and so on. So here, when the x value is 1, the y value is 4. When the x value is 2, the y value is 12. Okay, and so on. Really, what we're concerned with, this means the first term is equal to 4. If we plug in 1 for x, the value of the function is 4. The second term is 12. If we plug in 2 for x, the value of the function is 12. Okay, so here, I'm going to write this up. This means a sub 1 equals 4, a sub 2 equals 12, a sub 3, so remember the third term, if we plug in 3 for the x value into our function, the output value, the y value, is 36, and so on. Okay, so this is what's going on. So we want to say, well, is this arithmetic? Are we adding to get from one term to the next? Or are we multiplying to get from one term to the next? Now, I'm sure some of you can clearly see, to get from 4 to 12, we're adding 8. If we add 8 to 12, it's not going to get us to 36. So here, let's see, what do we multiply 4 by to give us 12? 3. And then 12 times 3 is 36. 36 times 3 is 108. So we're consistently multiplying by 3. Okay, if you have a hard time seeing that, just take any term and divide it by the term in front of it. 108 divided by 36, it'll give you 3. 36 divided by 12, it'll give you 3. Okay, so here, this is geometric, and our common ratio equals 3. That's what we're multiplying by to get from one term to the next. All right, so let's see. Let's write out our rule using geometric this time. A sub 1 is the first term. So we know, there it is, right there. There's our first rule. A sub 1 equals 4. Now, when you write a recursive formula, you also have to say a sub n is equal to the previous term, which we write as a sub n minus 1, now times r. So times, well, we said we're multiplying by 3 to get from one term to the next. So you can write it like this if you want. Now, me personally, I'm going to erase this. I like, instead of writing a sub n minus 1 times 3, I like to rewrite that. I always like to put the number first. So I'm going to rewrite that as, I erased my equal sign too. 3 times, and you don't have to put the times symbol. It's kind of like 3x. You don't have to put 3 times x. You could just write 3x. So 3 times a sub n minus 1. And that's my recursive rule for this example. Okay, now if you want to try out 3 and 4 on your own, it would be a good idea to just hit stop, try them out, and see how you do, and then you can hit play and see how you did. Okay, now these ones, I thought these two were harder than the ones above. With number 3, now I'm just going to give you a clue. When it goes from a positive to a negative to a positive to a negative, we can automatically rule out arithmetic. If you're adding, it's going to continue to go up if it's positive, or if it's, if you're adding a negative, it's going to continue to go down. This is going from a positive to a negative to a positive to a negative. So what that means is it has to be geometric, and r, what we're multiplying by, has to be a negative number. Now, some of you may be able to look at this and say, what am I multiplying 36 by? And I'm going to ignore the negative, okay, because we already know that the r is negative. So what am I multiplying 36 by to get to 18? What am I multiplying 18 by to get to 9? What am I multiplying 9 by to get to 9/2? Well, really, all these numbers are just being cut in half. So I'm just multiplying by, we already put the negative here, right? So by negative 1/2. Now, if that's hard for you to figure out, no big deal. You can use a calculator. You can take any term you want, okay? If we started this last term, 9/4, and divided it by the term in front of it by -9/2, it would give you -1/2. If you did 9 and divided it by -18, it would give you -1/2. -18 divided by 36, -1/2. So if you're ever unsure how to find the R or the D, all you have to do is take the term, take any term you want, and if it's geometric, you divide by the term in front of it. If it's arithmetic, you subtract the term in front of it. And if you're not sure, try out both. Okay, so now we know it's arithmetic and the R is -1/2. So all we have to say is the first term is equal to this right here, 36. And then we would say to find the nth term, that's going to be equal to the previous term. I'm going to leave a little space right there. The previous term times R, which is -1/2. And the reason I left the space is because I like to put that right in front. Although you don't have to, that's your choice. Okay, so this is our recursive formula. And this is a negative. I kind of blended it with the fraction bar. Okay, now for number 4. This one, the numbers seem to be getting bigger, but are they going up by a constant? Is it arithmetic? Are we adding to get from one term to the next? Well, I don't think so, because to get from 6 to 9, you're adding 3. And if you add 3 to 9, it's not going to give you a decimal. Okay, so it's not arithmetic, so it's geometric. So geometric, so what are we multiplying by to get from one term to the next? Well, if you're not sure, let's just take out the calculator. 20.25 divided by 13.5 is 1.5. Okay, even if you want to do this, 9 divided by 6 gives you 1.5. So here we know that our R is equal to 1.5. Okay, so let's write our rule. Okay, so we're going to use this setup. The first term is equal to, in this case, 6. So a sub 1 equals 6. And then a sub n is equal to the previous term, which we write as a sub n minus 1, times, and I'm going to put it in front of it, 1.5. So this would be our formula right here. Okay, so we're going to take a look at the next page, and this is where we're going to end today. So if we look at this, it says the recursive formula to describe a sequence is shown below. So this time they're giving us the formula. Okay, that's nice of them. Now they want us to find the first 4 terms. So instead of them giving us the terms and having us write the sequence, they're giving us the sequence and we're going to write the terms. Now if you look, this is actually a mix of arithmetic and geometric. Right? We're adding 1 as well as multiplying by 2 to get from one term to the next. So here we're going to do a little mix. Now, if we want to find the first 4 terms, that means let's make an answer box, right? We have to find the first term, a sub 1, the second term, a sub 2, the third term, a sub 3, and then the fourth term, a sub 4. So this is going to be my answer box. Now, the first term is the easiest because they gave that to us, right? You see it right over here? A sub 1 equals 3. All right, so now we want to find a sub 2. So we're going to use this rule to help us find the second term. So if we want to find a sub 2, I'm replacing this n right here with a 2. So let's write a sub 2. Now if I replace this n with a 2, I also have to replace this n with a 2. Okay, so let's rewrite this as 1 plus 2 times a sub, well, instead of writing 2 minus 1, let's think, what is 2 minus 1? 2 minus 1 is just 1. So instead of writing a sub 2 minus 1, let's just write this as a sub 1. Okay, so now we have 1 plus 2 times a sub 1. But don't we know a sub 1, right? Didn't they give that to us? They said it was 3. So I'm going to replace that with a 3. So that's why in a recursive sequence we have to use the previous term to help us with whatever term we're on. Okay, so then we're just doing 1 plus 6, which is equal to 7. So the second term is equal to 7. Now what you might want to do is you might want to just hit pause, try to find a sub 3 and a sub 4. Okay, you have to go in order because you need the previous term to help you with whatever term you're on, and use this rule to help you find them. Okay, so let's see how you did. So a sub 3. So if we want to find a sub 3, we're replacing this n with the 3, which we did. And now we could write 1 plus 2 times a sub, Well, if we replace this n with a 3, we have to replace this n with a 3. And since 3 minus 1 is 2, I'm going to make my subscript a 2. Okay, so let's rewrite this. We're going to rewrite the 1 plus 2. And since we know a sub 2, right, didn't we just find that? A sub 2 is equal to 7. We can replace this with a 7. So we're doing 1 plus 2 times 7. So 1 plus 14, which is equal to 15. Okay, so there's our third term. And then a sub 4, same thing. We're going to replace the m with a 4. And then we're going to rewrite this as 1 plus 2 times a sub. Well, if we replace this m with a 4, we have to replace this m with a 4. So 4 minus 1 is 3. So our subscript this time is going to be 3. Okay, so we can rewrite this as 1 plus 2 times, and I'm going to replace, instead of writing a sub 3, I'm going to replace it with what a sub 3 is equal to, which is 15. And now we just have to figure out what 1 plus 30 is, which would be 31. And there is our fourth term. So those are our 4 terms. So the first part is done. Now it says here, can the sequence be represented using an explicit geometric formula? Okay, explicit, we're going to talk about that later in the packet, so don't worry about that for right now. But geometric, we know that a geometric formula means that we have to multiply to get from one term to the next. And we already said we're not just multiplying. If this 1 plus wasn't here, if this was just 2 times the previous term, then wouldn't we be multiplying to get from one term to the next? But we're not. We're adding 1 as well as multiplying by 2. Okay, so, well, we're really multiplying by 2 first and then adding 1, right? So there's nothing you can multiply to get from one term to the next. So here, the answer to that would be no, because there's nothing we can multiply by to get from one term to the next. All right, so our final question for today. While experimenting with her calculator, Candy creates the sequence. This one right here, 4, 9, 19, 39, 79. Write a recursive formula for Candy's sequence. And then after that, they want us to determine the 8th term. Now, if we look here, we can see it's not arithmetic because this is plus 5, and then plus 10, and then plus 20. So there's no common number we're adding to get from one term to the next. And it's not geometric either, because if, I guess if you're not sure, like you could take any term. So let's say we take 39 and divided it by the term in front of it, 19. You would not get the same answer as if you took 19 and divided it by the term in front of that. So it's not geometric either. So this is going to be a mix then. So you really have to figure out what is going on here. And it might take a little bit of trial and error. But you really have to look at the numbers here. Hit pause for a minute. Look at them. Really think about it. What is it that we're doing to get from one term to the next? Okay, so I was looking at these numbers. And the first thing I said was, all right, let me just try something out. If I take 4 and double it, right? That doesn't quite get me to 9. It almost gets me there, but I'm 1 short. If I were to take 9 and double that, it would get me to 18. Like it almost gets me there, but it gets me 1 short. Every time I double it, it's getting me, I'm 1 below the previous term. So what that means is if I double each term and then add on 1, it'll get me to the next term, right? Think about it. If I double 4, that gets me to 8. And then if I add on 1, I'm at 9. If I double this term, if I double 9, that gets me to 18. And if I then add on 1, I'm at 19. Try one more. If I double 19, if I multiply this by 2, it gets me to 38. So if I add on 1, it gets me to 39. So what I'm doing is I'm just multiplying the previous term by 2 and then adding on 1. Okay, so let's see here. We first have to say our first term. So our first term we know is equal to 4. And then our nth term, we said we're taking the previous term and doubling it. So I'm going to put a 2 in front of this. We're multiplying it by 2. And then we also, in addition to that, have to add 1 to that. So this would be our rule for that sequence. So that was pretty tricky. Okay, now it says to determine the 8th term. Now let's think about it. We already know the first term, the second term, the third term, the fourth term, and the 5th term. So really, we don't have that many more to go. Okay, I wrote them out down here. So again, we know the first 5 terms. And what we said was we're doubling. If we want to find the next term, we double this term and add on 1. So 2 times 79 is 158. And if I add 1 to that, it gets me to 159. So there's my 6th term. If I want to find my 7th term, I just double this and add on 1. So when I multiply this by 2 and add on 1, it brings me to 319. And then finally, we want to get to the 8th term. If I take 319 and multiply it by 2 and then add on 1, it gets me to 639. So this is my 8th term. Okay, that's the answer to the second part of the question.